DeepSeek Harness gives developers an autonomous agent execution environment, but running raw web servers and managing manual CLI flags creates friction for daily engineering workflows. DSH Desktop packages the entire Harness ecosystem into a self-contained desktop runtime. It coordinates child process lifecycles, loopback networking, and plugin orchestration without sacrificing security or sandboxing boundaries.
Looking at the project repository, DSH Desktop acts as an independent desktop wrapper around the upstream DeepSeek Harness packages. Built with TypeScript and Electron Vite, it provides cross-platform binaries across macOS and Windows. Instead of rewriting the core agent engine, the project provides native operating system integration, background port allocation, and user data isolation across upgrades. The host architecture separates desktop control from agent execution. The Electron main process spawns an isolated node.js child process that boots the DeepSeek Harness runtime on an ephemeral loopback port. The desktop window points directly to this local instance with hardened web preferences, while persistent files like profiles, credentials, and logs are anchored safely in user data directories.
Port collisions and stale server daemons are completely eliminated. On startup, DSH Desktop selects a random available loopback port, starts the Harness instance in an internal launch directory, and runs readiness health probes. If the agent engine fails to boot due to a corrupted configuration or a broken plugin, the shell catches the error before displaying a clean native recovery screen.
Inside the main entry file, we see how the host runtime configures window Chrome and resolves theme attributes before the window even presents. The application reads user locale settings directly from local YAML configuration files and computes contrast luminances dynamically to blend the macOS drag region and Windows title bar seamlessly with the web renderer. DeepSeek Harness relies on a modular Cordis plugin architecture. When a user adds extensions or subagents, the runtime dynamically evaluates dependency graphs and runtime hooks. DSH Desktop manages this complexity by isolating plugin crashes, offering automated rollback scripts, and monitoring process tree signals across both Unix and Windows process groups. To guarantee that plugin installations succeed without relying on external system tools, the market installer constructs a self-contained runtime shim. It generates platform-specific command wrappers for Node and PNPM inside an internal desktop binary directory, dynamically updating the environment path before executing any plugin add or remove commands. Security boundaries require extreme discipline when hosting autonomous agents that execute shell tools. DSH Desktop enforces context isolation and blocks node integration in the renderer. Internal mutation endpoints inspect loopback source IP addresses and origin headers, while sensitive flags like expose internals are restricted strictly to the child runtime.
Sharing customized agents is streamlined through the portable .jpreset format. Presets bundle agent configurations, compositions, and skill definitions into validated archives. When importing, the desktop shell inspects potential secret leaks, checks version compatibility, and executes an atomic move to prevent corrupting existing agent profiles.
In the preload script, the application attaches mutation observers to intercept broken web UI states during boot. If a plugin throws an uncaught error in the Cordis web layout, the preload automatically injects clean recovery buttons into the DOM, allowing users to trigger an IPC call that uninstalls offending modules without manual terminal debugging. Traditional setups required opening multiple terminal tabs, configuring custom shell ports, managing background daemon lifecycles, and manually editing YAML configuration files. DSH Desktop consolidates this entire stack into a deterministic host process that monitors process health, provides LAN mobile bridges, and handles native OS dialogues. The desktop app bridges multiple layers across the DeepSeek agent architecture. It interfaces directly with third-party model providers, upstream Cordis plugin registries, the community plugin market, and local file systems, providing a unified developer surface for autonomous agent experimentation.
The architecture offers undeniable strengths: seamless setup, resilient plugin recovery, zero configuration local ports, and strict process sandboxing. However, being pinned to early release candidates means upstream breaking changes require patch package updates, and lack of Windows ARM64 support leaves gaps for specialized hardware. DSH Desktop demonstrates how to package complex, terminal-heavy autonomous agent engines into reliable desktop software. By offloading agent execution to supervised child processes while keeping the host UI strictly sandboxed, it provides a compelling blueprint for modern AI developer tooling. Explore the repository and build your own agent pipelines.